One SI unit that you're probably not familiar with is the concept of the mole, often abbreviated just by getting rid of the E at the end to leave us with mole or moles of a particular substance. It's a way of calculating the amount of particles in a large sample of atoms or ions or uh, molecules or formula units. And it is something that is not completely unfamiliar to us as a concept. In life, there are many situations where we have words that are used to express a number, sometimes large and sometimes small. Let's look at a few examples. When I think of the word pair, I think of a pair of shoes or a pair of glasses. And that word pair represents the number two. So here I have two boots, and I can say I have a pair of boots if I wish to. Other words that represent a number, a dozen. A dozen means 12. We often refer to a dozen donuts, but it could also be a dozen pens. It could be a dozen glasses. It could be a dozen roses. 12 is what the number represents. It doesn't matter what the object we're counting is. If I have a dozen of that object, I have 12. Other words, a gross. This one is probably the least familiar for you, but a gross is a dozen. It's equal to 144. When I was a kid and we would go purchase fireworks on the 4th of July, we would often buy firecrackers by the gross. You would get 144 in a package. Here are a dozen eggs. There are 144 eggs here. So a gross represents that particular number, 144. If I make copies in the copy room, you'll often run into packages of paper that look like this. Each one of those packages contains 500 sheets. That's known as a ream of paper. If you had 500 of anything, you could call it a ream. We have all sorts of words that represent a particular number. In chemistry, the mole is exactly the same concept. It represents a specific number of things, and it doesn't matter what those things are. 6.02 times 10 to the 23rd. Like if I wrote it out, it would be 602 and then 21 zeros that followed it. 6.02 times 10 to the 23rd is probably the largest number that you've ever seen. And it is a absolutely enormous number. And it can represent the number of atoms in a mole, just like the number 12 can represent the number of donuts in a dozen. How big is it? Well, it's really big. You can find all sorts of fantastic examples on the internet, but here are a couple of my favorites. If you tried to count from 1 up to 6.02 times 10 to the 23rd, you would die before you got there. Even if you counted by 1 million. So you said 1 million, 2 million, 3 million, 4 million, 5 million, and you tried to get to 6.02 times 10 to the 23rd, you wouldn't get there. You would die before you got there. It would take too long. If you got the world's fastest supercomputer to count by 1 million all the way up to 6.02 times 10 to the 23rd, you'd die before it got there. It's just an enormous number. In fact, it's so big that if you were to go out to the football field and place marshmallows across the surface of the football field, a good estimate would be that would not even come close to 6.02 times 10 to the 23rd. In fact, if you covered the surface of the planet, it would not come close to 6.02 times 10 to the 23rd. If you covered the entire surface of the planet with marshmallows, that is. If you stacked marshmallows on top of one another until you had 6.02 times 10 to the 23rd, you could cover the surface of the earth and probably have a pile of marshmallows, maybe 100 miles deep, maybe even much larger than that. So it's an enormous number. Why would you ever want a number that big? Well, you use numbers that are big to count things that are small. So, what are things that are small? Well, a sodium atom is a really, really small thing. A water molecule is a really small thing. And so using a large number like 6.02 times 10 to the 23rd to count very small things is a great way of counting without having to actually individually count each and every single one of those items. So let's talk about some calculations that we typically do. And we'll start with our simplest calculation and we'll get to more advanced calculations as we move forward. What if I were told that I had 2.2 moles of sodium and I wanted to know how many atoms of sodium that actually would be? This is a very simple math problem. It's a dimensional analysis problem. And if you wanted to, you could just start with what you know, 2.2 moles of sodium. Left the E out that time, that's okay. Draw a line, and then you just have to know that in 1 mole of sodium, there would be 6.02 times 10 raised to the 23rd atoms of sodium. An atom is a type of particle. A particle can be anything that you could count. And so atoms, molecules, anything like that, ions would also work. So let's do the math on this. On my calculator, I'm going to say 2.2 times 6.02 E23. Let's talk about how you get that E button or that E symbol to appear. So I'm going to say again 2.2 times 6.02. And then on the typical TI calculator, you're going to hit the second button and then find the comma. And the comma is usually placed right above the number 7. So if I say 6.02, second comma, you should see an E. And then after that E, you're going to type 23. That syntax, that format for your calculator means 6.02 times 10 to the 23rd. And it's the easiest and best way to type it into your calculator. So when I do the math, this is what I get. I get 1.3 times 10 raised to the 24th, and that is atoms of sodium. Let's have you do another problem on your own. What if you were to convert 3.15 moles of calcium into atoms of calcium? It works in exactly the same way. So pause the video here and come back to see my solution when you're done. Pause right now. Okay, welcome back. Hopefully your answer is going to line up with mine. I have 3.15 moles of calcium, and I'm going to convert that to atoms in the same way that we did before. 1 mole of calcium is 6.02 times 10 to the 23rd atoms of calcium. So on my calculator, I'm going to say 3.15 times 6.02 second comma, which is E, 23. Hit equal, and I get 1.90 times 10 to the 24th, and that is calcium atoms. Let's see what would happen if we went in the reverse direction. What if we went not from moles to atoms, but what if we went from atoms to moles? Let's say I've got 4.21 times 10 to the 19th tungsten atoms. And I want to turn that into moles of tungsten. So this problem is exactly the opposite of the one that we just saw. I'm going to say 4.21 times 10 to the 19 atoms W. Draw my line. And I need to know that there are 6.02 times 10 to the 23rd atoms of W in 1 mole of W. It's really important that you type this into your calculator correctly. So I want you to listen closely. Here's how I would do it. 4.21 second comma to give me that E button. 19. Then hit divide. 6.02 second comma to get the E button. 23. If you do that math, your calculator should say 6.99 times 10 to the -5 moles of W. That's all there is to it. We're going to learn a few other types of conversions, but we'll wait for another video. Until then, I'll see you soon.